Welcome everyone to the first Belgian Elastos Meetup here in the Red Loft in Ghent. And thank you all for coming. So I have the honor to welcome here part of the Elastos team, Mr. Rong Chen, the founder of Elastos, and the mastermind guy.
Yeah, thank you.
Mr. Kevin Zhang, the head of the developer community, and Mr. Kieran Pasha, the moderator of the Reddit and Telegram channels, and also evangelist. So the timetable for today, we're first going to start with a presentation of Rong Chen about Elastos and how this blockchain-powered smart web can support large-scale apps. Will be a talk of around half an hour, I think.
Yeah.
Then we go over with the talk of Mr. Kevin Zhang, who will talk about the Cyber Republic and the future of the Elastos community. Then a little talk from Kapil, Kiran Pasha. And then we go over into a Q&A where you can ask all the questions you want. Let's start.
Okay. Yeah, I got the, I probably got the mic already. Yeah. Well, it's an honor to be here. This is really the first time I come to Belgium. The reason why we start this Elastos project was actually very simple. I started this project. I gave it the name Elastos. I started the project 18 years ago. It's a year 2000, a long time ago. And I came up with the name Elastos around 2002, which is 16 years ago. And actually at that time, the whole reason was trying to build a so-called network OS. Because if you think back, Elastos, I got lucky enough to come up with the name. It means two things. One is elastic compute. Elastic compute was actually to create virtual machines in the cloud, right? Because as long as 20 years back, we start to have this feeling that the virtual machine, the network is coming up because of previously the operating systems. Until today, most of the operating systems are actually device OS. Device OS meaning the operating system only take care of the machine. Anything go off the machine, actually it's not the operating system's responsibility. It's the app developers' responsibility to send network packets to wherever they want with the blessing of the operating system. But if the consumer uses the application and his information is stolen, or his machine got hacked, or a bunch of machines go hack someone else's machine, actually the operating system vendors always blame on the consumers not being careful. You forgot about your password, you didn't install antivirus software, somehow you did something wrong, right? In real world, how much should a consumer know, right? And it's really consumers are not the ones to blame. So actually it was the software, by and large, a community should take care of their customers. And actually that kind of understanding lead us to design a so-called network OS. So network OS comparing to device OS is that simple name because of 1992, the Java inventors actually came up with this slogan, the network is the computer. That was 26 years ago, but not many people took it seriously. But think back, even those founding fathers of the internet had this idea of doing the internet decentralized. It was 50 years ago, 1969, 49 years ago. So there are a lot of things, so there's genius ideas behind it, but until today, we can finally put all the pieces together. One of them, of course, a critical part is the network OS. Network OS being the OS doing all the heavy lifting, doing all the network traffic, right? Handling all the network traffics, sending and receiving messages without allowing, I emphasize the word, just without allowing or prohibit any applications or services from sending any network packets. They're not allowed to open sockets. They're not allowed to send IP packets at all. That's an absolute word. So only in that way, the user, the consumer data could be protected. Actually, there are three parties. There's a consumer, then there's a software developer, then there's the operating system, right? And consumer generate data, and the software developer, because so many of them, applications, they require you give them permission to read your address book, to allow the application to be able to send a message. I don't know how many of you realize, right, when you install a Android app, it asks you for permission for making a phone call. But actually, why should I let the application being able to make a phone call? Right? Why should I let the application have the right to access my location? I mean, so consumers' right is not guaranteed whatsoever in the past. Then it's the application has the most say. If you don't give them permission to open up your address book, the application won't load. Right? They just find all excuses. And then there's this operating system. So when we talk about blockchain, often we see there's a word called on-chain and off-chain. On-chain meaning the smart contracts running and solve some of the problem, like without a middleman, we can bet on a Belgium-England game, soccer. But then in order to get the score, the smart contract has to go off-chain to get the score. So if you look at I guess most of you are into this blockchain or cryptos. So a lot of public chains, they all have on-chains, and none of them actually can solve all the problems. So they have to resort to something called off-chain. So there's a common denominator of off-chain. But then ask yourself, what is off-chain? Off-chain actually is the web. It's the internet, correct? So why don't we say it loud and clear, you know, because you have a blockchain and you have a web, correct? And that's why we have this smart web powered by blockchain, because the logic is this: all the public chains, they all need a off-chain, they all need a web. But if the web is not secure, how do you know, the Belgian and England game, the soccer game, the website is genuine? How do you know? Because of there's a website, there's a DNS translation, because the internet does not use like ESPN.com or CNN.com. In reality, the packet actually is an IP packet. And if it's an IP packet along the way, because it's a decentralized multiple hops, and it's already a hop, the gateway actually manipulated the data and returned you the fake message, correct? Without guarantee of the off-chain, without a guarantee of the web, really the smart contracts can do very little. It can't do much. But since still we're in the study, in the research period of the blockchain, because so far there's not much real mobile applications using the blockchain. So the problem is not as obvious. It's just as if a lot of viruses on Windows, not as many viruses on Linux. It's not because of Linux is safer or Windows is better. Well, I'm not saying either. Actually, they're equivalent. But the reason why there are more viruses on Windows is because Windows has at least 95 to 99% of the PC market. So there's no reason for the hackers to hack Linux because they don't make profit out of it. If they hijack your PCs, they potentially got more chances to succeed, right? To get ransom paid. That's a simple reason. So 20 years ago, we had this understanding maybe there's a way to solve this problem by managing all network traffic on users' behalf, on consumers' behalf, Remember, the consumer, the operating system, then the software, right? The operating system representing the consumer right, and in a way eliminate the power use or abuse the internet by the software. So in the blockchain terminology, who is the largest or most likely to be evil middleman? Because we're saying D-apps, what? Decentralized apps, and getting rid of the middleman. Who is the largest middleman on earth, right? Because think about it, if user produce contents, and if I make a short video, if I make audio, if I write an ebook, and I need to resort to something to play, media player, because if I share my short video in the social networks, it's easily copycatted, so I cannot make a profit out of my data. I cannot monetize. So what can I do? I have to give it to YouTube, I have to give it to some social networks, so to share, and hoping that they give me a small cut by my video being played 1 million times, and because there's an advertisement in front, after, and so the website could give me some share, right? But is it possible for media player not telling me the truth? Let's say the video being played 1 million times, but the video player told me it's only played 100,000 times. Is it possible? I'm not saying the media player is evil or not evil, but is it possible for the media player not telling me the truth? Right? Definitely it's possible. Because I'm the guy making a video, how do I know how many times my video being played? I have no idea. So in my understanding, the largest, the biggest possible middleman actually is the media player. And if you think of the media player, who is the media player? By and large, in the IT world, in the internet world, actually all software are middlemen. Because if you have a doc, it's being played by Word. If you have a PDF, it's being played by Acrobat. If you have MP3, it's played by media player, correct? So because user generate contents through something called software, and the data being played back still by some software. And if I'm saying I own my own data, really, if I don't own the code, I don't own my data. If I don't own the piece of code, I cannot monetize my data. So when we talk about value internet, when we talk about asset internet, when we talk about we're sending Bitcoin peer-to-peer, we own, collectively, we own the Bitcoin source code. Because the source code is running autonomously somewhere by the miners of the world. So no single organization, no single government is running the Bitcoin. So kind of we have the trust in that now. And who are the believers? There are about at least 40 million to 50 million believers now. It's large enough. So then, if you think I can send you a Bitcoin peer-to-peer, in fact, we both own the software of Bitcoin, correct? But then if we want to send an ebook, we want to send a video peer-to-peer, do we own the code that interprets the ebook, that executes the short video? We don't. If we don't own that piece of code, we don't really own the data we made. That's the actually what intrigued us to build Elastos 16 years later. That's 2016 when I first learned Elastos. I learned a blockchain. So I find out Elastos and blockchain might have a synergy, and to put the two things together and to create a magic. So that's the two ends. One is the network OS, basically taking over all network traffic. Make sure you want to go off-chain, find a website, because the website names actually is registered on the blockchain, which you can have relatively high confidence that's the website you're looking for. And also, all the users on this smart web have IDs, registered on the blockchain. And I'm very happy to announce that Elastos decentralized ID went live online yesterday. And we just had the sidechain released, we just had the decentralized ID released, and also we have the decentralized network, the peer-to-peer network released in April to GitHub. So together, if you put all the pieces we released so far, we're hoping in a month time or so, we're going to mix the two and make a decentralized carrier. So what is a decentralized carrier? In one sentence, the decentralized carrier actually is the off-chain, the common denominator of all off-chains, we hope, right? That's the smart web. And also the other way to understand the smart web is actually carrier. You can think of Orange, SoftBank, Verizon, the phone telco carriers. So the telco carriers actually, if you have one phone, telco carrier give you a phone number. I have a phone number, so I dial the phone number, I get to you. That's peer-to-peer, virtual circuit peer-to-peer. So what we're doing is we give decentralized IDs to virtual machines, so that one virtual machine can call the other virtual machine peer-to-peer. But then there's a big difference. If you call through carrier, telco carriers, the telco carrier gives you the number, and of course they can revoke the number. And also they can eardrop on the conversation we have. And of course, if we have a blockchain, we got the IDs from the blockchain. So somebody was asking me, because so far most of the team members were in China, and is that a Chinese project, right? And since this is a blockchain project, do you have the confidence, right, that all the source code are open sourced and actually it's run using the Bitcoin mining machines? So we do merge mining with Bitmain, with all the Bitcoin miners, and we will release the code by the end of this year. Currently it's working, but then for security reasons, we haven't released to public yet. But then given that said, you get the IDs from the public chain. So it's really not controlled by any organization, not controlled by any government. And also, if I dial the number from one person to another person, we got the public keys, private keys from the blockchain. So all the messages are encrypted peer-to-peer, and without fearing someone eardropping or intercepting our videos. So that's why we built this decentralized carrier, right? And it's based on the blockchain. Secondly, this kind of a decentralized carrier really is to convey videos, video calling, video conferencing, and file sharing, messaging for the mobile phones, and decentralized remittance, decentralized gaming. So those are the basic characteristics of a decentralized carrier, which is fundamentally different from the peer-to-peer network of a blockchain. Peer-to-peer network of the blockchain only do the broadcasting of the ledgers. They don't do video conferencing, they don't do BitTorrent. So that's completely two different kinds of peer-to-peer. They're both peer-to-peer. But there are two kinds of peer-to-peer, right? One is dedicated to build this decentralized ledger. And the other one actually is dedicated for the smart homes, for the mobile internet users, correct? So that's why we need this two-tier peer-to-peer network. And the one really that what the blockchain one is so-called on-chain, and the real peer-to-peer network actually is what they call off-chain. But guess which one is bigger? Which one requires more engineering work, correct? Given BitTorrent, eDonkey, Skype, so right now the peer-to-peer network, because collectively with all the source code, open source, and putting them together, even putting them together is a big engineering effort. We started this effort 2012 under the investment of Foxconn, because 2002 we started doing this network OS. And 2012, we started to do this peer-to-peer network. So today, we have the blockchain, right? So put the three things together. Blockchain is the on-chain. The peer-to-peer network is the off-chain. We call it decentralized carrier, the orange without orange.com. You see what I'm saying? And, but then if you think about Orange has mobile phones deployed all across their network. So now, given 2012, our understanding of virtual machines, can we have virtual machines everywhere on top of this decentralized network with a number I can dial, or the network traffic's being auto-generated, so no one can steal other people's information, no one can launch DDoS attacks. So that's really the logic behind it. And when you think about peer-to-peer, if I can use one phone to call another person's phone, that's that's peer-to-peer. But if two phones are peer-to-peer phone, in computer scientists' point of view, it's just a computer. It's specialized, right? Good for personal use because I can put it in my pocket. A supercomputer, on the other hand, is faster, but I cannot afford or cannot put it in my pocket. But it's, in theory, that's different computers. For example, Google.com. Can you imagine Google.com? Of course, there are millions of computers behind Google's website. But then, in our mind, that website could be replaced by a super fast single computer with vast amount of memory and huge, unlimited number of hard drives, right? And they can crank out code so fast, and if I search Ghent University, and can come up with tons of answers. You know, whether the answer is done by one computer or by a million of computers collectively, I simply don't care. So in that sense, Google.com is just one computer. So if I call Google.com, it's still peer-to-peer without fearing someone in the middle intercepted or eardropping on the network. So what I was just saying that the most evil could be the media player on my phone, the software. The second evil actually could be the carrier intercepting us, right? Of course, the third evil, the third middleman, is the website. Even though the website is one computer, but then since in the past I cannot monetize my data on my PC, on my phone, I have to give up my data to YouTube, to Facebook, to let them handle my data and hoping they'll pay me back in a fair way. But then, of course, they could manipulating data without telling the truth. So what I'm saying about saying is that when we see the word Dapps, decentralized app, we want to have more money to us, have less money to the middleman. But who are the middlemen? The media player, the carrier, the website. They are all more. They take a much bigger market share than the smart contract. What's the smart contract? Then I'm talking about I finished talking about this off-chain, then I'm talking about on-chain. The Bitcoin, actually, the blockchain is done by multiple parties. They are not there for speed reasons. Like Google.com has millions of computers behind. Collectively, they share workloads. A million computer is faster than one computer, PC-wise. One PC behind the Google.com versus a million PCs behind Google.com. Because you can do, when you do search of Ghent University programs, some PCs are searching their biology, whatever, right? So collectively, they come up with a list all about Ghent University. But on the other hand, for blockchain, you have many computers, millions. They need, because they don't trust each other. Say we are going to the first grade, report to our teacher, and she taught us 1 + 1 = 2, and we have like 30 kids in the classroom, and you know, one kid might make a mistake. So, but then collectively with 30 kids, they're all doing the exactly the same spreadsheet of math problems, and collectively a majority wins. Then they handed in a report, here's the answers to all the questions from the teacher, correct? You have a better chance of getting correct results. And so that's what blockchain is. Blockchain is there for redundancy. It's not for speed. And if you have smart contracts executing on the 30 nodes in sequence, right, or something you broadcast, of course, it's not quite in sequence. One guy had the chance recording and then broadcast, and they are verifying the result and collectively save it in the ledger. So what I'm saying is this self-programming never existed before Satoshi. This is programming is very novel, very creative, so then we can trust the ledger more. But on the other hand, the blockchain is not for speed. And more importantly, collectively, 30 kids doing the calculation, but they come up with one answer, one ledger, right? That ledger, we can trust it more. We believe it has a good chance all the results are correct than a single kid. So we have more trust. But then that ledger is not decentralized, actually equivalent of one student doing. If one student doing, we may not have as much trust. So the ledger is really for trust. If it's one ledger cannot be decentralized or distributed logically. Apply your common sense of language, right? And because we have more trust into the ledger, what it can be used to decentralize is internet has multiple parties. If the internet has Google, Apple, Amazon, Microsoft, Facebook, who is the bigger brother? Who can they trust each other? If they don't trust each other, can they trust the blockchain, give them IDs? Can they all trust the blockchain doing the fair and square verifications or notary public for them all? So what I'm saying is the blockchain is a very, very new thing, and there to establish trust among multiple parties. And actually, where do they have multiple parties? Not the blockchain. Not because of their multiple miners. It's really the off-chain is the key battling field, right? So that's why when you go back to research blockchain projects, they brag about doing Dapps or transaction per second. I hope my talk can give you some common sense. Competing TPS on the ledger, there is some reason for it, but then definitely that's not the key to the blockchain technology. Whether you're fast, of course fast might be a little better, but then not necessarily. So fast is not something for the blockchain. It's the trust we have to rely upon the blockchain. And the internet has multiple parties, which needs to be decentralized, which needs to be establishing trust between themselves, right? And secondly, with this kind of trust, with the virtual machines, we want to convey not only data, we want to transfer code peer-to-peer. And transfer code, when the virtual machine loading the code, there's a chance to verify against the blockchain. Do you still own that piece of game, or do you still own that piece of ebook? Otherwise, we cannot build a virtual smart economy. So in order to build a smart economy, we need that kind of virtual machine to find out viruses and to verify the scarcity of the digital assets. So those are really, really not that hard to understand if you know about Orange, if you know about why scarcity can create merchandise, can create a economy. And I think that's pretty much concludes my talk. I'm just giving out the rationales behind why we want to do this Elastos project. Okay, next I'll have Kevin talk about the community. Because this project is too big for one person or one group, that's why we're here to build a community.
All right. First, welcome. I'm Kevin Zhang. I'm from San Francisco, California, somewhere called Silicon Valley. It's my first time to Belgium. When I was in US, I was told that America has no history. I didn't get it at the moment, but now I realize when I'm walking down the street of Ghent, I see the old historical buildings, more than about 1,000 years old. I was like, wow, it's a weird some places really have history. And yeah, I'm very happy to be here and talk to everybody here. I have 3 topics today about Elastos. The first one is I'm going to give a real case study, what Elastos can do with other blockchain company, blockchain product cannot do. You know, if you go to the coin market cap, there are about 1,000, maybe a couple thousand of products, and each one claims they're doing blockchain. And I read a lot of the white paper, but I hardly get what's different between them. You can now say, this is Bitcoin, this is Ethereum, and we are exactly the same as Ethereum, but we are based in China. We are exactly the same as Bitcoin, but we are in Japan. You cannot do that because blockchain itself is worldwide. There's no border at all. So we're always looking for something that's very unique. It's different. It's doing something that other product cannot do. So that's why I'm here to share with you what is the product or the features that Elastos can do, but other blockchain product cannot. So that's why I'm giving you a case study. And in order to understand that, I may spend a few minutes about talking about the few components of Elastos. We try to make it as simple as possible. I have assumption that most of you already know something about blockchain. So I don't need to go through the basics, say what is a block, what is a chain, and why they're mutable. I don't want to go through that part. I want to focus on which Elastos is different from those basics. So that's the second part. The third part is we are talking about the Cyber Republic. Cyber Republic is a new concept we introduced. That is a way how we organize Elastos, how we use the money of Elastos, and how everybody can join together to make a new economy. So that is third topic. So let's start from the beginning. The first one. Before I start anything, I need to thank all the organizers of the trip. You know, this European trip, we actually visited 6 countries. Belgium is the last 2. All of Meetup, including this one, is not managed by us. It's managed by our community leaders. So I have to thank everybody here. They just volunteer. They help us to organize this kind of meeting, not only in Europe, but also in Asia. Americans, globally, it's organized by our community, not by us. Okay, here's a case study. I use the name Movie Coin, but that is not a real project name. We haven't signed a contract yet, so I'm not authorized to disclose the name of the project, but you will know in a few weeks. This is from another startup company. We're trying to solve a problem which existing for many years in the movie industry. Actually, I didn't know too much about movie industry before, but just recently just learned from those teams. So the problem of a movie industry is a few problems. First is in some country, maybe not in Europe, but in some country, people turn to buy the private copy. So they don't pay to watch a movie. They can easily either download from some private site or using some P2P network to get the movie to watch for free. So they don't pay to watch, so the movie maker cannot make enough money. Another problem is for the movie makers, especially from some independent movie makers. They're not big name at those in Hollywood. They're not famous people. So even they have a very good script, very good story, but they cannot, or maybe hardly to find enough money to shoot a video. And the third problem is the distribution channel. You know, movie industry was pretty old, but 100 years old. All the distribution channel was all dominated by a few big companies. So a smaller movie makers, they actually cannot have enough power to push the big distributor. Also, because it's not very transparency. the movie maker doesn't know how much money actually it get from the distributor. They can tell you the movie is good, you got $10 million. Maybe I can tell you, oh sorry, your movie is not good, you got only $1 million. You don't know, right? It's not transparency. So the movie maker don't trust the distributor. And another problem is the consumer may not pay for watch a movie. So that's a big problem in this industry. So they're trying to find a solution using blockchain. How they gonna make everything transparency, especially when they try to convince the investor to invest into the movie. And how you have to say, oh, this is in transparency, your investment, your ROI is guaranteed. And the other part, they have to convince the consumer to pay to watch the movie. So that's the problem, how we're gonna solve that using blockchain and our smart web. So this is something I'm gonna tell you today. It's unique. I can tell you, not any other project can do that in using one end-to-end solution. So before we get into that, we have to go through just a few minutes, go through the basic concepts. Just 4 major parts of the Elastos. I try to make it as quick as possible. You just get some idea. You don't need to go very deep. If you want to go deep, it's very deep. I can tell you. But one or two days, I can keep talking. It's very deep. But I try to make it as surface as possible. As long as you can understand the next part, it will be OK. So I was asked many times, Elastos is a blockchain project or not? Yes and no. First, we are a blockchain project. You can see we have a blockchain here. But we are not only a blockchain product. We actually have more than, we claim ourselves as a smart web powered by blockchain. It's actually, if I was asked to use one word to explain, it is a new internet. It's not the one we use today with HTTP connect to a server, so push you some information, you get some HTML media or something like the old internet. But the new way we use internet is what we currently provide to you. That is new internet. So the new internet actually including a few layers. Of course, we're starting from the bottom up. The blockchain, of course, and Bitcoin, that is a base layer. Yes, we do have a blockchain, and it's pretty complicated blockchain. We're using the merge mining with Bitcoin as a POW. And on top of that, we also have main chain and set chain structure. The main chain, actually, we call the ELA chain. ELA, E-L-A, is our token name. And that is very simple, very basic, because that's by design. We don't want any complicated logic into the main chain. We want the main chain to be as stable as possible. Just like Bitcoin. You know, Bitcoin has been running for about 10 years. There's a lot of money in it, right? I believe every second there would be some hacker trying to hack into it to get some money. But so far, still very stable, running for 10 years. Nobody maintain it. Why it can make so stable? Because it's very simple. We're gonna do this the same thing. We make the main chain very simple, but we move all the logic into the set chain. The set chain is made by the developers. You can deploy your own set chain. You can put all the logic there. You want to run the Ethereum, okay. You want to run Neo, okay. You have ideas to run a different kind of consensus model. Fine, you can do whatever, but that's our set chain. The main chain will only have like a hash from the side chain to have like a proof for existing put into the main chain. So your logic, whatever you have, but you always have one hash to point to the main chain, so we know the side chain is there and the hash of each block. So the design like that can prevent something happened a few months ago in Ethereum. You know, some popular game like Crypto Kitty. A lot of people playing the game, and because too many people playing that, it's blocked the Ethereum main chain. Our design actually can fix this issue. Then it's possible you still block your set chain if you have a crypto poppy or something in your set chain. You can block it, but you can no way to block the main chain and other people's set chain. So in that case, we decentralize logic to your set chain, not the main chain. We try to keep main chain as stable as possible. And also we do the merge mining with Bitcoin. So in that case, if you are a Bitcoin miner, you don't really need to buy a new machine or upgrade your existing mining machine. You just upgrade your software. You actually can merge, can mine the ELA as well as you mine the Bitcoin without additional energy consumption. So that's a kind of a reward to the miners. And on top of that, it's more important, it's carrier. You can see the black line over there. That is our P2P network. We use the carrier to replace the HTTP and the HTTPS. You hear right. We replace the HTTP, which is belonging to the backbone of the old internet. So why we do that? Okay, simple reason. Right now, if we go to any website, including some of the famous decentralized applications, some famous DApp like CryptoKitty, you still need to go to some website to download the code, right, using HTTP or HTTPS. So I consider this still a centralized solution because there will be a server there to feed the data, feed the code. But what if the server is crashed, the server is breaking by some hackers, this application will no longer running. Or if there's some database, centralized database, you have your privacy data into the server, and because there is some valuable data there, there's always a big bite for the hackers. They might try to break in. So if there is server is centralized, there always be a risk to lose your data or be hacked by some hacker. So that's why we think, how about we decentralize the transportation layer? So there's no server at all. We just peer-to-peer. Every peer is equal to others. When you're trying to contact another server, you don't know where it is, you don't need the IP address. You only need an ID. So the DHT, dynamic hash table, connect all the nodes. They actually can help you to find where, like, a routing to that nodes. Even if the node is behind the firewall, we can still penetrate the firewall to get that node. So in that case, there will be no server. Even if some of the nodes was torn down by whatever reason, firewall, censorship, whatever, as long as there are amount of nodes still running all over the world, you can always eventually get to the point. So that is how the peer-to-peer network running. That is almost the same as what we use for BitTorrents or like a Napster download music, something similar to that. We use the DHT. So that is a carrier. So you can see it's serverless. In this case, serverless, no HTTP. And also, all the content sending from one node to another is encrypted. So only the node who has a private key to know the content. Everyone in the middle, they don't know what's going to transfer. They just transfer as long as they know the ID. And on top of that is a more important part we call the runtime. That is a virtual machine. How we define the virtual machine is similar to, let me see what is the best example. There is a, just like if you run an application, and the application is not run directly on top of the hardware. There always be something in the between. It's a typical called operating system. And what if we want to make application running on Android OS, iOS, and Mac OS, Windows, Linux, so many different operating systems. So how we can make the application running on all of them? So if there is some middle layer, the middle layer running on different operating systems, but your application running on top of this middle layer, then your application can be virtually running on all the operating system, right? So this middle layer we call the virtual machine. The runtime is actually a virtual machine, but it's not for the compatible reason. We made that as a sandbox. The sandbox means your application is running inside the sandbox, and we block all the traffic to outside the world. That means the application itself think it is running in a real machine, but actually it's not. You are running in a sandbox. All the API call is handled by the sandbox. But why do we gonna do that? The reason is we're going to block all the traffic, and anything you're trying to contact the outside world, we will block it, and we will use a carrier to send it to the right node. One good example is if you are virus everywhere, especially if you are using Windows machine, you are likely to get some virus. The virus is actually running in your code and you don't know. It is trying to send something to a hidden server somewhere and take all the information like your password, whatever your private information saved to a server you don't really know. Steal your information. But if the same code is running inside the sandbox, it won't work, even there is some virus in it, because we block the traffic. When the code trying to send information to somewhere like hidden server, the HTTP is blocked. They have to tell the virtual machine they're trying to do something. That is make the on-the-table deal above the table. So that in this case, we actually can know, oh, your code is modified. Your code is affected by a virus. You're not gonna do that anymore. Also, as long as the code is modified, if you know a hash function, the basic concept of the blockchain. So as long a binary is modified, whatever, only 1 bit or 2 bit modified, the hash of the application will be very different than the original one, right? It's a hash function, the benefit of the hash function. So when the application is made, or application components is made, all the information, the ID or hash, will be saved in the blockchain. So when the RT start application, they always check the hash of each module or each application compared with what was originally stored in the blockchain. If somebody modify any part of the application or any components, the hash will no longer match. So in that case, the RT will warn the user or just disable the launch of the application. We can make sure the application is exactly the original built by the original developer. So in that case, if somebody modifies that code, it will not run. So that is a charming of the runtime. And above the runtime, there is an application. Now we have a web app, native app, and we call the D app, the decentralized application. So D app is running in the sandbox. Sandbox running operating system above, and there is a carrier layer transfer information, and there is a under layer blockchain like a database store everything. So this is the structure of Elastos. You can see it's much more complicated than regular blockchain projects, because a regular blockchain project usually only have a blockchain layer. They don't care the above layer. One example is the typical D-app game like CryptoKitty. Yes, they're running on Ethereum. They have smart contract, but you still have to run it inside your browser. Most likely, you still have to install a plugin called the MetaMask to contact using Web3 to contact the Ethereum virtual machine. But we actually bring you everything in one sandbox. You actually can easily use it. It's very user-friendly. All right, this is a basic of Elastos. Now let's go back to our previous case study. So back to the movie coin. So how are we going to solve the problem of the movie coin? So the first question is, if people want to get a private copy without the payment, how they can still watch the movie or not? No, they cannot. The reason is based on Rong just mentioned. We turn all the digital assets or copyright assets or content into application, into a executable application. So a movie is a movie D-app. A game is a game D-app. A book, e-book, is an e-book D-app. So in that case, if you want a movie, you play the game, you read the book, you need to run the application. Remember a few minutes ago I tell you, if you run the application will be checked by the runtime to make sure the application is not modified. So in that case, if a movie maker make a movie without a feature to save the movie data as a plain text or decrypted movie file, so you cannot save as. That means when you watch a movie, you can watch it for sure, but you want to right-click to save as a file, you cannot, because there's no such a feature. And all the files sent to your DApp is executable, that the content of the movie is encrypted. It's encrypted using a special key. And that key has to be unlocked using the hash of your ID, your personal ID, and a hash of your virtual machine ID, the hash of DApp ID. So in that case, anybody who actually pay to watch the movie, the browser, no, sorry, the DApp when start, they need to check the blockchain to find the ownership of this particular copy. If you actually pay for watch, you can easily find, oh, you are the owner of this particular copy. And they also check the hash of the RT hash of the DApp, make sure you didn't modify it. Then you can ask for the smart contract, give you a unlock key. And as long as you have the key, you can unlock and watch a movie without a problem. But if you, first, you cannot save it. Second, even the same DApp, you give it to another person, it cannot run because the key is different. The key is related to a user ID, the RT ID, the app hash. If you modify any of them, the key will no longer valid. You have to ask again. But in this case, because you are not the owner, you didn't pay to buy it, your ID will not in the blockchain, you can check. You are not the owner, so you don't allow to watch it, you don't have a key. The first problem solved. Second, a distributed channel. Of course, we don't need distributed channel because the carrier is a channel. So anybody can download a ebook movie to watch it. So there's no channel needed. You don't need to go to go to a cinema to watch it. Second, a third problem is the cross-funding. So in that case, you as long as your income is guaranteed, you actually can do an ICO for your movie in our ecosystem. Just like this. It's complicated. I forgot to turn the page. Actually, we should get to this page earlier. So when this site is the app, the movie maker. So if they want to shoot a video before do that, you can do something like a Kickstarter. Like I tell in the ecosystem, say I have a movie, the story, and how much money I'm gonna need, how many copies I'm gonna produce. So the investor, anybody who buys the token to own a portion of the assets or a copy of the movie. So for example, I'm gonna have 1,000 copies. So I just say I'm gonna issue 1,000 of a token, and if you agree on me or you trust me, you can buy a token. As a kind of investor. And once you have the token, your ownership will record it in the blockchain. And I can have the money, I can shoot the video, and after the video is done, I will use our DApp to generate 1,000 of unique DApps in the system. Every DApp is different, have a different key. And you are one of the investors, you own one of the copy. And after that, the original decrypted copy will be destroyed. So in the world, there only be 1,000 digital copy. You can watch it, or you can watch your copy because you own it. And if you want to sell it, you can sell the copy in the digital marketplace. So anybody who wants to watch a movie, they cannot go download because there's no any open place to download. They have to buy from the second market. So in that case, you actually own your data. You own your own data. Not only you get some subscription, you own it. And you can resell it. So if you are a social influencer, you actually can own a copy of a movie, like one of 1,000 copies. Then you can tell the people, like in your YouTube channel, in your Telegram, you can tell everybody, oh, this movie is really awesome. You got to watch it. Then you're going to sell your copy on the market with higher price. If a lot of people want to watch it, but fewer sellers, you can sell for a higher price. So you can see this is very different than the original industry, right? Very different than original. So originally, we pay to subscription from Netflix or Amazon Prime. What do we got? We didn't get a lot. We didn't get nothing. We just got a right to subscribe for a month or a year. But after that, we didn't own anything. You cannot resell what you have, right? You lost that. But in this new business model, you actually own it. You can resell it for profit. That means you own your own asset. This is what we call ourselves is an internet of wealth. That's internet of assets. which is very different than other projects. Well, to make it short, the last thing I'm talking about is a separate public. This is important, but I put it into last, not least. Separate public is not a country, right? If you try to find it in Google Maps, you cannot find it. It's a virtual community, how we built our Elastos community. Elastos is not a company. We're not organized as a company. Like Rong is not our CEO, I'm not CTO either. We're just a community member. When we start Elastos, if you go to our white paper or the Genesis blockchain, you can see there is almost a half of the ELA, the token, is reserved to use to build a community. It's a 16 million. Now the total token is 33 million. 16 million, about a half, is reserved. So those money will be used to build the ecosystem, to reward people who actually contribute to the ecosystem. Contribution including like you write your code, you contribute your time testing the code, or you help us to set up or organize this kind of events, or you just shoot a video and tell people like I like Elastos, whatever, or you can run a service in the system. Whatever, it's all counted to be a contribution. So we use the money as a bounty program to all people to help us. And we organize the people not like the traditional company, like we are boss to tell you what to do. No, we don't do that. We always encourage people as a citizen of the Cyber Republic, you tell us what you're gonna contribute. Like you give us a proposal, and including your budget. And we have a console there and evaluate your idea. If you think we think it's good, we give you some bonus. Then you can use the money to do whatever you think, and we can check the progress from time to time. And the council will be elected from the people who own the ELA, the citizen of the Cyber Republic. You can vote, you can decide how the money is going to be used. We are going to release our constitution in about a few weeks. In August, we're going to release our first constitution. So everybody, you can join the Cyber Republic, and you have your right to vote to decide how the ecosystem gonna work. So this is the Cyber Republic. So today I'm going to welcome everybody to the Cyber Republic. The website is there. It's called cyberrepublic.org. And right now it's at the stage of public beta. So there's not a lot of really useful information in it. Just I encourage people to try it. Test the website is also a bounty program. If you find a bug, we'll give you some kind of ELA as a reward. So we may not get your rage, but at least you get some feeling of you are in charge of something. Like you are part of the Cyber Republic, and you are one of the citizens of Cyber Republic. We may issue some passport, but may not be used for travel purpose. All right, that's for my talk, and I will give you another case study, a real person case study. I'm going to invite Karen. He is one member of our Cyber Republic. He gonna share his story about why he joined Cyber Republic and what he's currently doing, and what is the future of Cyber Republic. So he's gonna share his own story. Hi, come on.
Multiple microphones. All right, I'm not here to talk about any sort of technical details today. I'm just going to share my story of how I joined the Elastos community, how I heard about Elastos, and how what I will continue to do for Cyber Republic and all the community members that are planning on joining our community eventually. Hopefully we'll have most of the people here today join. But to get started, I was born in Nepal. I moved to the United States when I was 14. I got my bachelor's in computer science and software engineering, and I started working. I worked as a software engineer, and for the last 4 years, last 2 years, I was in the cybersecurity department, and then just last December, I actually heard about Elastos. Or before that, I hadn't even heard about blockchain at all. And my cousin actually introduced me to Bitcoin, and you know, it was around the time when Bitcoin was rising rapidly back in December, and you know, we were really naive, and he thought that just by buying one Litecoin we would be millionaires someday. So I bought one Litecoin. I was really proud. I just wanted it to go to 20,000 like Bitcoin did. It never did. So that was how that was my entry into this new world. I knew nothing about it, but I think around December 23rd or 24th, I heard about Elastos, read their white paper. It sounded really interesting because coming from a software engineering background, I could really relate to the kind of problems, and also in the cybersecurity department, I could relate to the problems that Elastos was trying to solve. And I started to look into blockchain research about other blockchain projects, what they were doing, learned about, you know, all the details, intricacies with what blockchain is all about, like, you know, learning about smart contracts, how they work, and started there. And Elastos, you know, the more I read about Elastos, the more I was interested in becoming part of this this open source community, because you know, everything that they did or do is completely open source. All the code is open source on GitHub. Anyone is free to contribute in their own way. And I started reading a lot of documentation about Elastos, all the different tech side of things. The one problem that I saw, you know, on our Telegram channel and our Reddit channel was not a lot of people actually understood what Elastos actually was, because it was trying to do so many things, and it was really, and because blockchain is still in its infancy, it was really hard to wrap your head around the kind of technology that is involved, and so my job, you know, because I myself came from a very non-tech background. When did my bachelor's in computer science, I could kind of relate to, you know, the kind of questions that they were asking. So I thought, you know, maybe I'll write some, you know, guides, beginner guides, which is really non-tech friendly. So I got started with that, wrote a non-developer beginner's guide to Elastos, teaching about different sides to Elastos, how they work, how they interact, what this new internet, new smart web is going to look like. And so I started to, and then I was invited to pretty much be a moderator for Telegram and the Reddit community. Got started there. And so I started writing articles and making videos, and that's how I became part of the community. And back then, I was actually already working as, you know, in another company, 9 hours a day. I was also doing my master's at the same time, and on my free time, I was dedicating some of my free time helping the Elastos community understand what they were trying to do. So, you know, a few months ago, actually, well, a month ago, Kevin asked me to dedicate all of my time to Elastos so that I could, you know, put in 100% of my effort. So that's exactly what I plan on doing by joining Cyber Republic. Two of the technical, I didn't want to go into technical details, but I will share how Elastos is really, really different compared to other blockchain projects out there. I know that Kevin and Rong already mentioned a lot about Elastos, but I did want to touch on two things, I guess. First of all, Elastos, as we've been talking about, it's not only a blockchain project. it is a network operating system project where blockchain is one component, and then we have the runtime, which is the virtual machine, that is another component, and we have the decentralized carrier, our peer-to-peer network, which is another component. So when you combine all three of these things together, that's when you form the smart web, which is free of man-in-the-middle attacks, free of DDoS attacks, distributed denial of service attacks, virus attacks that are prevalent today in the industry. You hear all these news, oh, some DNS server got hijacked and a lot of traffic was directed to somewhere else, and a lot of these things are still going on today. So those are the kind of fundamental problems that Elastos is trying to solve. So in a sense, there is really no, everyone has a hard time explaining Elastos in just one sentence, but I'm gonna try to do it today for the first time, so we'll see how that goes. So if I were to explain it in one sentence, I would say Elastos is a virtual ecosystem where applications have no direct access to the internet, where they run in this sandbox environment, where all the users, their IDs are recorded in the blockchain, their ownership of digital assets, and the flow of traffic is completely taken over by a decentralized peer-to-peer network. Okay, so what does that actually mean? There is no centralized server in Elastos. Every application, when you think about Ethereum decentralized application or any other blockchain projects out there, they're really not pure decentralized, as Kevin was mentioning earlier. I would say they're hybridly decentralized because the only thing that they use blockchain for is running smart contracts on their VM. A smart contract is pretty much an if-else logic, which you cannot tamper with. And then for everything else, for like the off-chain, I don't know why I guess it just sounds cooler to say off-chain than the internet or web. So anyways, for all the data storage and the traffic and all that, that is still, they do need to go to some server to grab that data. So in that sense, some of it is decentralized, using blockchain, smart contracts, and then majority of it is actually centralized. So what Elastos is offering is a new way, actually not just for consumers, but also for developers. It's making it really, really easy with their software development kit and their platform, where you don't really need to learn a whole lot about blockchain, or you don't need to know how the details about how it all works. If you already know, if you're already a developer, then Android developer, iOS developer, just a regular web developer with JavaScript skills, whatever the case may be, you will be able to just use our platform and develop your applications like you would in your traditional framework pretty easily using the kit that we provide. So that's kind of, that's the only technical sides I'll cover. But I'm going to talk a little about Cyber Republic. When we talk about Cyber Republic, it is not just for a developer community, it's actually for everyone. So you don't have to be a developer to contribute to Cyber Republic. If you're a developer, yes, you can contribute to the core code, find some bugs, fix it, or maybe you have a really good idea to improve upon the existing technologies that are being used. So what you do is submit a proposal how you're going to fix it, and then the entire community in the Cyber Republic votes on that idea. And then if it is approved, along with the amount of ELA that you would like to get started as your funding, from the council, then you can just start working on the project, and you can, if you're successful, then you'll get rewarded with ELA, and your idea that you had, which started with an idea, it actually can be part of this Elastos platform going forward. So in that sense, Elastos is not only creating this decentralized internet, but also a decentralized community where you don't have to live, in the U.S. or Belgium or anywhere. You can live anywhere and still contribute. So if you're a non-developer, you can also contribute in your own way. So let's say you really understand Elastos and you would like to, make some tutorial videos or demo apps or whatever idea that you have. You would go through the same procedure. You would sometimes we'll actually have all these bounty tasks already present, You'll be able to take those. Let's say one of the bounty tasks might be, explain what this technology is with, lots of diagrams, blah blah blah. And then as a YouTuber or social media influencer, you would try to explain it in an article or video, and then you get rewarded in Ella. So that's another way of contributing. Another way is, around 16 million are reserved for this Cyber Republic. But where we see Cyber Republic going forward is we're not just going to be using those reserved allocation, but you'll be able to conduct entire businesses as part of the Cyber Republic. You might have an idea, a team, actually a grand idea, and you actually own a lot of Ella. If you would like to, crowdfund this, actually have your own startup, building this really awesome application, you can submit your proposal. You can look for team members, developers from the Cyber Republic community, and then get it up and running, and then you can pay them with some Ella. So, and then they contribute back, and then you make it decentralized, and then you can form your team that way. So there's a lot of things that you can do at Cyber Republic. So you can think of it like a digital country, pretty much, where the economy is run using our Ella token. But obviously, you can, so yeah, with Ella token. The goal is to actually, we already have the website live, cyberrepublic.org. We also plan to convert this website into an Elastos DApp running in the future, so where everything will be decentralized from then on. So there's a lot of ways that you can contribute, as a developer, non-developer. I hope we can all, you all can join us in this grand project that we're trying to build, completely decentralized. And I think that concludes my talk. Thank you. Q&A.
Is there a microphone for the audience? Yeah.
Yeah.
Is that really working then?
Yeah.
It's working? No.
It's working.
It's working?
Oh, it's working.
Hello?
Yeah.
Is it working?
Yeah, it works.
So first of all, congratulations for the product.
Thank you.
Impressive. But I would like to know what's the biggest weakness of Elastos. If it goes wrong, where it goes wrong. For instance, blockchain, for Bitcoin, it goes wrong in 51% attack, right? If you have 51% of the power.
51% attack.
Exactly, yeah. When you have 51% of the mining power, you can attack the blockchain, and you can make your own transactions, double spend, and so on. So where does Elastos go wrong?
Well, Elastos actually, we are doing joint development with Bitmain at this point. Actually, we do have the code working. The modifications are not that big project. But then, as I said, we are doing so-called merge mining. So basically, the same machine, very machine, can mine Bitcoin and Elastos coin at the same time without consuming extra power. So for miners, they can get multiple coins at the same time. On the other hand, if you want to tamper with Elastos ledger, it'll be as hard as you modify the Bitcoin ledger as well. So in theory, it's possible to launch 51% attacks, but in reality, because there are so many miners out there in the world for a blockchain, a Bitcoin ledger, and in practice, it's pretty hard to launch 51% attacks against Bitcoin.
I like 2 cents. Oh, okay. Because we do merge mining with Bitcoin, It's not like other smaller projects. It could be at the beginning because not a lot of nodes running. It could be like a 51, easily get to 51% of attack. But if we do merge mining with Bitcoin, there are already thousands, millions of nodes running to mine Bitcoin. So I don't really think it would be easier to get to 51% attack. It's much harder.
Perhaps I understand my question right. The question is not the mining itself, but to the whole project, the whole and all the code of Elastos. Where can go wrong? So it solves virus, it solves many sorts of malicious attacks, but which sorts of other malicious attacks can now happen because we are doing things differently?
Let me try to rephrase the question.
Yeah.
So he's asking, what are some of the problems that Elastos might face? He's not really asking about the 51% attack that might happen, but what other hurdles that we might face in the future?
Potential problem. Okay. I think the first problem we're facing right now is we don't have enough developers. We need more people to join us to complete the project in time. Right now, we have 2 teams in Beijing, Shanghai, in China. Currently, we're still in time. We're still on time to release the product. And these few days, we're going to release the ID sidechain. And next 2 months, we're going to release the first version of Elastos. So we're still on time, but we try to get more developers to work together to make it faster. So this is, I think, it's the first challenge. The reason is everything is new, and no other projects try to do such a big scope of the project before. So this is the biggest challenge. Technical-wise, I think the next challenge would be how we can interoperable with other blockchain. Like there are already some Dapps running on top of Ethereum. They already have a Solidity smart contract. I don't really think they would like to transfer to a new one. So we're currently working on to migrate existing EVM. EVM means Ethereum VM, to our sidechain. So in that case, we can compatible with existing Dapps, so they can make easily migration to our system. And in the long run, we're also thinking another new way to run the smart contract. That means you don't really have to, like Ethereum, you run the smart contract in all the nodes and do the same thing as one piece of code running 1,000 times. It's not very smart at all. We're working on some new way to run smart contract based on your demand. You want a super secure or less cost, so you can choose between 1 to 100, and based on your selection, we can choose a subset of the nodes to run your code in their carrier machine. So we can also do a Byzantine fault tolerance to make sure that the answer is correct. So if we can make that work, that means you don't have to learn a new language like Solidity to write a smart contract. You can use your existing code like Python, JavaScript, Ruby on Rails, whatever you have. You can still use the logic and put that into the smart contract, and the code will be running in our carrier node. We will have like 3,000. How many carrier nodes are we going to run by the end of the year?
40,000.
For
40,000 hardware pieces.
Yeah.
So actually, we're after we're releasing the alpha by late August, we plan to have about. So far, we signed up much more, but then we commit around 40,000 hardware, like smart routers, NAS, or set-top boxes, or smart speakers. All together, we're going to install around more than 40,000 hardware pieces, nodes, peer-to-peer nodes in homes. And secondly, we try our best to migrate 400,000 consumers, application users on top of the smart project, on top of the smart web. Because that said, actually no one is really using the web. They're using an app on top of the web. So actually, that said, in order to have 400,000 users, we have to have several DApps partners. So we're going to serve our DR partners Actually, we have already started with like Zapier to do mobile IPFS, to do decentralized little games. So then we can distribute games peer-to-peer. We can distribute short videos peer-to-peer by the year end.
Let me add something to that. So one of the problems that I think most other blockchain projects are facing and will continue to face in the future is adoption and traffic, which is pretty much why our partnership with Zapier is very important, because they already have an app running in these third world countries out in Southeast Asia and South America and everywhere else, where it's really costly to transfer data from one person to another, where they're really big. They already have millions and millions of users. So the goal is to maybe migrate some of their user base to the decentralized application that they are building on top of Elastos, so that we don't run into that same kind of adoption and traffic problem that most other blockchain projects are facing today. Another thing also is we're really making it really easy for developers to come in and just join us, because we provide everything from if you want to create like a token, we'll make it very easy to do that, for your movie token or something like that. There's a lot of use cases here, but one particular use case I don't think we have talked about is, let's say you wanted to just write, you're just one person team, and you have a really solid idea and you would like to develop an app. In the market today, in your Android or iOS, it's pretty easy to develop an app and then just push it to the market. It'll be as easy as that, because what you can do is, you can start with, let's say you want to run your smart contract. When you start, obviously, you want security, but maybe you want it to be less costly. So you can maybe have one node running smart contract, and then as the user base grows, then maybe you can expand to use, many other nodes for your smart contract execution. So that's just one of the ways that you can get started pretty easily without having to commit a lot of resources. And then, using Cyber Republic, you can actually hire other people in the community to work for you or work with you to work out all the kinks and details about your grand idea that you might have. So yeah, we have thought about all these problems that are prevalent today. We're just trying to look at those one at a time. So hopefully we get there.
Mm-hmm. And also another challenge, you can hold it. Another challenge is also the risk is the bubble. A lot of people, and maybe myself is agree, there are bubbles of the blockchain. And you can see there are thousands of projects in blockchain right now. And if I was asked to predict, I believe a pretty much amount of the projects will not be successful, because the world doesn't need so many public chains. There are only a few of them can be survival after 1 or 2 years. So that's why we're trying to make sure everybody understand Elastos is very different than many other blockchain projects. We are unique. We'll try to distinguish with others. So even some of the public blockchain project failed, and the Elastos is very different. We do different things, which we do go different approach. So I don't want to the bubble burst from other blockchain can be affect us. That's why we're trying to, every time we explain Elastos, we all say it's different. You need to know what Elastos is unique. So you don't consider Elastos is yet another blockchain project. As long as everybody understands that, we are safe.
I'll add my last, sorry. Just going back and forth with the same question. All right, this is the last thing that I'll say. So Elastos, you can think of Elastos as the common denominator, where we're not really competing with any other blockchain projects out there. We actually encourage to collaborate with them, and then where they can build their own chains on top of Elastos and actually work with us, because the unique structure that we have, the main chain, side chain, it actually has a lot of other benefits too, where in the world of today, there's so many public chains out there that are trying to run many applications using the same chain, and if you wanted to interact with some other chain, it's really hard to do that. Because it's not an easy thing to have that interoperability. So when you have this unique main chain, side chain structure, you have all these side chains in Elastos. They all trust the main chain, and so if you wanted two side chains in the Elastos world, these side chains will still not trust each other, but they still trust the main chain. So they can actually establish trust with each other using the main chain. That's where the power, even if the main chain is very, very simple, it establishes trust amongst all the different blockchains that might be part of Elastos and actually work with them. So you might have an application that might want to run, a smart contract on Ethereum VM, for like part of your code, and then you can actually have another piece running on another. You can have a lot of imagination. Imagination is your limit. So that's what. All right, let's move on to the next question.
Next question. Can you pass the microphone? Okay, thank you.
Hi, I just have a question regarding the example with the movie coin. Like if, for example, a few hundred million people want to watch a movie, where is that movie going to be stored? Because if you store it in a blockchain, it's going to take a lot of, for example, a HD quality movie takes like 6-7 gigabytes. Like you're going to replicate a copy of the movie all the time, or you keep it in one server?
I can start and then you can go ahead. Yeah, okay. So the question was, how are we going to store all these different movies? There might be thousands of movies, games using blockchain. We're not using blockchain to store movies. The long answer is we actually have two kinds of nodes. One is the mining node, which is taking care of our blockchain piece, which Bitcoin miners are actually merge mining Bitcoin and then Ella, and then any other side chains that might merge mine on top of Ella. And then there's another kind of node, which is the carrier node. And these, you can think of them as, we'll have these super nodes or relay nodes, where we'll also be using as Rong was mentioning earlier, IPFS, mobile IPFS. If you know like how IPFS works, that's pretty much how data is going to be distributed, across many different nodes. So when you actually want to stream, you might have a master copy live somewhere behind your router in your home, but then the cached version will be divided into maybe, I don't know, however many pieces all across these nodes, and then the carrier is going to look for the nearest. Let's say I want to watch a movie that just came out and I purchase it. So what it's going to do, it's not going to go back to the original master copy, because that person might not have a very high bandwidth to serve like thousands of people. So what it will do is it'll look for the nearest, as Kevin was also saying earlier, it will use a dynamic hash table to look at the nearest node which actually has that copy, and then put it together and then do the streaming that way using super nodes and stuff. So those are different kinds of nodes.
Thank you.
And you were asking an engineering question. Actually, there are many solutions on that. I can give you one example. Like IPFS. IPFS is a store all the data as like a Merkle tree. So each node, or I don't know, call a node or something, it's just a small portion of the whole movie data. Right, so if you want to watch a movie, you need to know where each node store the different node, and become a whole tree that you can watch the whole movie. So where the node is stored, that sequence is a data. So in that case, we don't really need to store all the 1,000-copy movie to different copies over the internet. That's waste a lot of storage. We still save the like 1 million pieces of the movie in the node, but the sequence of the nodes is a data. The data is encrypted using a key. So in that case, you have to unlock the sequence. If you have a sequence, you know where you can find the movie data. So that is one easy solution, maybe not easy, but one solution to scramble the movie data into a encrypted way. So that is one solution. We have a lot of solutions actually like that. We haven't decided which to go yet, This is only one solution. We also consider other solutions, how we can scramble the data to store in the IPFS without a lot of abundancy, but we still can, redundancy, we still can keep the data secure. This is an engineering question, not the economy question. But there are many solutions I can tell you, but we can choose one of them. We haven't decided yet. Next question?
Can you?
Yeah.
So I have a short question about the Elastos ID. As I understand it, it's kind of the cornerstone of your security. And then I think the most important thing there is the translation from the assets to the ID. Is there some kind of verification process to make sure there's no impersonation there or anything like that?
I'll repeat the question first. So the question was, the backbone of this new smart web is going to be using our decentralized IDs, where you're asking if there's any way for someone to tamper with that ID. Is that a correct assumption?
For a similar asset, how will I know that if I want to reach a certain asset, that I have the right ID to go to that? There's not someone else is impersonating the same asset.
Okay, I'll try to get started with that. So our DID chain is actually going to be released today or tomorrow. That's where we have the wallet upgrade to take care of that. But to start with, ID, that we call it the ID sidechain because it is a sidechain, because nothing is stored in the main chain. Just as on starting from a ground level, you may have many different transactions in these ID chains, and only one hash for each block from the sidechain will get into main chain. That's how the trust is established between sidechains. So you're asking, how will you know if you are the correct owner for a particular digital asset in the, using the ID, right? So every device, every user, every VM, every DApp actually has a unique ID. And whenever you purchase a movie, like that case study that Kevin was showing, what happens first is the content creator actually creates, like, let's say 1,000 movies, and then after he creates 1,000 movies, they each have different ID. They have 1,000 different IDs, and they're all recorded on the blockchain. Originally, all the ownership belongs to the content creator, and then he or she puts it onto the digital market store, which is by itself also decentralized, by the way. And then someone else can go in. Actually, one thing I also forgot to mention is with these movies, they actually, when you say you own a movie, you actually own a movie token, because that's how you're going to be transferring this ownership. So what happens is content creator, puts it into the digital marketplace, and then there's a buyer that wants to buy it. They go to the store, and then they purchase one copy out of this 1,000 copies. When that happens, the ownership of the content creator will then decrease by one. So the content creator will have 999 copies, and the last one that the buyer just purchased will belong to this new buyer. So the ID, because every user has a unique ID, all these IDs are actually tied, and ownership is tied and recorded in the blockchain. So that's how this is going to take place. Anyone else has anything else to add? Yeah.
Hey, you already talked a bit about your roadmap and an alpha coming out, but when would us IT geeks be able to start playing with the Elastos components, like running a carrier nodes or playing with runtime?
So the question is, when will developers actually get their hands dirty into developing an application using all the services that we provide? So I'll let Rong answer that.
Actually, last May we had our first hackathon because we released decentralized carrier code in April, and we also released so-called personal cloud drive in April. So. Of course, we invited a few teams, small teams, to our office to work on a 48-hour hackathon. And of course, with decentralized carriers, what most people did was like a decentralized Telegram, text mode, no UI, basically command line. You can talk to one another across the world, and decentralized way. And of course, build on top of that, like we're going to have the decentralized ID now. We're going to merge them together, and we do have the smart web working in the lab, but I'm not sure about how far the SDK has been released, how much has been released, and it's step by step. And today you can actually download the decentralized carrier. There are people doing some small games, and there are people doing some other things. I personally don't know. It's there, and hopefully by end of August, we're going to have at least the browser, and since we have the macro websites, and you can start to do the end-to-end from browser to macro websites without HTTP.
So the summary is, by August, we plan to have an alpha version, and then you can start playing with whatever we provide. You can already start playing with the code. Some of the components that are already open source, like Carrier, there are already like demo apps running using Carrier. The only thing that doesn't actually use blockchain. The Carrier component is one piece, like we mentioned, and then the blockchain is another piece. The DID, the decentralized ID chain, is another piece. Main chain, side chain, it's all, we're trying to get it together and then put it at sort of this whole package by August, so that developers can dive into their own test environment and then start developing their apps. Other questions?
Yeah, we also open the question to the online, like people watching the live streaming. You can ask a question on YouTube. We can answer the question online as well.
Do we have any questions online? No. Okay.
If I understand the question correctly, do you have any metrics in place for reserving as decentralized IDs to prevent name whales and so on, to reserve a large amount of decentralized IDs?
I'll repeat the question and I'll let Rong answer that. So the question was, do we have any preventive measures to prevent these whales from collecting all these DIDs or their unique names, so that they can just get it like the early days of the internet, where someone, if they were to grab google.com and they would sell it later for like millions of dollars. Are we doing anything to protect that? Is that the question?
Yeah.
We just released our own sidechain, because actually at this time the sidechain is very primitive. So you can think of it like Bitcoin wallet IDs. So some sort of IDs, but just not registered on the ID chain instead of registered on the main chain, which is, you can think of it like collecting all the wallet IDs into one place instead of scattered all around the ledger. That said, actually, no single man could collect a lot of other people's IDs, right? Because it's a 256-bit number. You collect millions of them, it doesn't really make much of a difference. And you can always create more. That said, of course, we're also thinking, we thought about domain names, like, for example, I want to be called rongchen.id. But yeah, because similar projects like Blockstack have done something similar. I talked to the engineers for a short period of time. The current thinking actually is not to create a Elastos rongchen.id domain name. We tentatively think we should use, like, we have a decentralized app called Elastos. That's going to be the smart web browser. Actually, it is a browser code base, and we just yank out the HTTP part, right? The only thing the only website that the browser can access actually is the local host, 1.7.0.0.1, and with a hash. And the browser going to everywhere in the world without you knowing it, without the user directly entering the web address. That said, if you look at your mobile apps today, some of the apps require you to log in using Facebook or log in using WeChat, for that matter. So we are doing this decentralized app. We don't have a central server, yet the app requires you to log in, say, using Facebook or using WeChat, whatever you prefer. And of course, that means the ID is qualified by the social network. So onto our decentralized IM chat program, there you can say literally my Skype ID is Chen.Rong. Chen.Rong, that's my Skype ID. And but then if the name is qualified by Skype, then we'll put Chen.Rong and a Skype logo, and or some Facebook logo and a WeChat logo, right? So then, in the decentralized talks, you'll see not only the name, you'll see a little picture, that icon qualifies your name. So we don't want to immediately go into this centralized way of dictating of how much money we should charge for Rongchen.id, for example. So maybe we reserve the right to do that in the future in a decentralized way, but that's just the other way. Sounds easier or more decentralized.
Other questions?
No question?
We got a question on the audience.
You were explaining the part of having the consumer and connect directly with the operating system without the middleman. I personally work for a telco. So for a telco, like a Horizon.
Telco.
Are there solutions telcos can use the Elastos solutions for their benefits? I'm picking your brain, but
I'll repeat the question. I'll repeat the question and then I'll let him answer. So the question was, we have a member in the audience working for telco, and they're asking if there's a way for them to utilize Elastos in any way in their platform or their environment. Is that the question?
Well, what we're seeing actually for the past 20 years is that there should be a way to get rid of media players. So actually to have the user content scrambled into games and playing in the virtual machines directly, right? That's basically what we've been working on and off for the past 18 years. The telco, so if you think of currently we have phones deployed across the telco carrier network. And then what is, so there's a trend actually building software-defined networks and building virtual machines. Both concepts are relatively new comparing to how many years the telcos has been around. And you can imagine the hardware right now, it's more like some Asians believe in reincarnations. The hardware is more like the body, and there's a spirit, which is the virtual machine, like a genie embedded into this hardware. When the hardware is gone, too old, too slow, or you lost it, you buy a new machine. Then this new virtual machine will come migrated and docked to this hardware. That's the model, and underneath there, we hide all the telco protocols, like whether it's a satellite or fiber or microwave, or it's encrypted. All those carrier details are hidden from the virtual machines. So which we call it computation is orthogonal to communication, meaning when you write programs, you shouldn't be aware of the communication at all whatsoever. So this theory is not new. This theory, I've heard it at least for 20 years now. And like it or not, that's where everybody's moving into. It just depends on who is moving a little bit faster or a little bit slower. But to us, we're just completely open sourced. That's yet another dimension, right? Not only we're moving, we're also opening it up completely, because to gain trust from top to bottom. So in that case, definitely could be used by telcos. Actually, telco has some first mover advantage because the model, really, think about it. Telco has been around for about more than 100 years now, which is peer-to-peer. Now we call it virtual circuit. Now people are moving the virtual circuit on top of the decentralized internet. The internet is called a packet switch, a decentralized packet switch. And the virtual circuit is something built on top of the, currently people are moving into building this on top of the internet. So for example, for those non-techies, have you heard of VoIP, VoLTE? If you look at your iPhone more carefully, they have those settings. Whether 3G, pick your settings, carrier, and go into 3G, 4G. Then also there's a button, radio button saying VoLTE, whether you pick it or not, right? Actually, you do have a choice. Everybody has that choice right now. Basically, what that says is you are using the telco network on top of the internet instead of on top of the telco network. You have a choice today, and that's where everybody's going. So all we're saying is make it based on blockchain. So because we don't want the carrier to be dictated by like one company, because after all we're working on the internet, people should have a trust into the neutrality of the network. And but then in terms of engineering work, that's a huge amount of engineering works, right? Because let's say telco, you have satellite, you have undersea cable, you have all the switches, routers, all the different cities. Those sophistications, logically they're simple, but engineering-wise, they're really hard. That said, whichever carrier realize the importance and have the first mover advantage, I do think this is the time, the telco merges with the internet. And because of, think back, internet is decentralized. No one owns the internet. There's an advantage, there's a disadvantage. Advantage of that decentralized internet is every country, everybody can hook up to the internet. The disadvantage of that is everyone can fake the identity, could hack the network without any regulation agencies to stop them, right? So that's where actually telcos, even, we have two tiers of network. One is still we have the physical network, the internet, and we have the virtual network and virtual machine. Physical machine and physical network, we have two tiers. And telco actually is at the physical level. They have a lot of heavy lifting to do. For example, the operating system is going to take care of all the sending and receiving packets. And who is the operating system? Who composed of this operating system, right? In Europe, the heavy lifting still has to be done by the local carrier underneath. And in Asia, it's done by some Asian carriers. In US, it's done by some US carriers. How are you going to do that, right? Without the consumers know. And I think that's a huge business opportunity there. For example, because there's only one carrier now, it's all generated, can you design a router and changing the authenticator on the fly, make the network so secure?
Let me add my 2 cents. I think it's just a good opportunity for telcos. I used to work for telcos before, so I know like the internet was started, there is some rumors in the telcos. They don't really know what they can handle the trend of internet back to 20 years ago. Actually, telcos are playing very important role in the internet world. So does for the next generation of a blockchain world. So telco has a big opportunity. And for example, like we trying to decentralize everything, including the storage or the processing. So in that case, telco has millions of customers. Likely, we're going to push the storage or the processing from the central server, which was in Amazon or in Google data center, down to the each family. So very likely, if you are running a broadband company in Belgium, likely you have millions of users. Every user have a home router. The router eventually in the future will become a smart router. Smart router means it run a node of a carrier, run nodes of IPFS, running a node of our smart contract. So in that case, all the users who already using your service not only pay the service fee, but they can also, by running like the node, they can get some benefit from other people. So in that case, if the money they earn is higher than the cost, they actually can use that for free, and you can take the money from the telco as a new business model. It is possible, but I haven't done any kind of detailed calculation on that, how much, where is the break point, I don't know yet, but it's a trend. So in that case, we actually can decentralize most of the power from the supercomputer to everybody's home. And because a lot of traffic no longer need to go to the central server, but it's just served by local traffic. So your backbone will be less traffic than right now. The one example is I use a lot of IoT devices in my home, my garage opener, my doorbell, almost everything, my sprinkler. Actually, it's all connected on IoT router devices. But right now, all the traffic will go to the somewhere in Amazon server. So even somebody knock my door, press my the door ring, the camera takes a picture, not directly to my phone, even I'm home. It sends a message, the video to Amazon server, and in my phone, go into my router and get the image. It's a kind of huge round trip. But once we put all the smart contract, all the IoT devices on the separate, decentralized small network, the message actually doesn't need to go to the Amazon. It just go to my home router, to my phone. It's just a short circuit. So in that case, the telco can make the backbone much less traffic than right now. But because you own the users, you actually can own the a lot of mining power or traffic power. That is a very new business model. Maybe it will change how we use the internet at home today. So I'm not sure in Europe, but in US, many people using ADSL or cable to connect the internet. It's ADSL, so it means the download speed and upload speed is different. Because most people, they don't upload a lot, they just download a lot. But in the future, this new kind of demand that a lot of home routers need to upload a lot of data to the other server, other nodes. So in that case, we may have to modify something, our transportation layer, to make sure the individual user also have a much larger upload bandwidth. Right now it's very small, but maybe in the future they have to make such a change to fit the new decentralized internet world. It is possible, just my forecast. All right, thank you.
It was quite complex. I didn't get all of it, but most of it I got, so thank you very much.
Thank you.
Yeah. From the internet.
So I have two more questions from the chat. One was to cover the Chinese government view about Elastos, since it's a communistic country, and more about centralization and decentralization.
So I'll repeat the question. So the question is, shoot.
Let me repeat the question. Yeah, the question was about the China's governance, because China is a well-known communist country. It tries to do everything centralized. So how we can deal with that kind of governance, right? Is that a question? Oh, you wanna answer? You can answer.
Well, first of all, as I said, this project has been going on for 18 years. I was born in China, raised up in China. But I was also one of the very first those new immigrants going to the United States, because China was completely closed up before 1978, and then after 1979, China established diplomatic relations with the U.S. and start to have students going to the United States to do grad studies. I was lucky enough to be as I said, one of the early few. I went to the United States January of '84, and the code right now is completely open sourced, and the reason why I found the company in year 2000 in China is purely because I was grown up there. I had some connections who would like to invest in me, because at that time I couldn't get any American VCs. And Currently, of course, given the white hair that I got, and I do have some friends who became government officials. And that said, actually, yeah, a lot of propaganda both sides, I mean, in the US and in China against each other. But in reality, a lot of Chinese right now are allowed to travel. And of course, a lot of foreigners are allowed to travel to China as well. So the exchange of information actually is still there, very open. That said, Chinese government right now is regulating ICOs exchanges for some reasons. They have their own reasons. For example, because we know the ICOs, 90% of them, basically it's a vaporware, it's just an error coin. And then because it's an overpopulated country, and also people likes to gamble, like it or not. And so it causes some problems, right, for families, because it's scarce of resources. For every little opportunity, a lot of people jump on. So there I can understand the government side of it, but of course there are some other issues. The Westerners could not understand, for example, freedom of speech, right? That's another thing which is very sensitive in China. We're not here to be political. We're here just for the technology. We want to build a new internet for the world. And as I said, I truly believe the internet should be neutral to any government, to any organization, to any company, to any individuals. Okay, that's my personal belief. I say it clear and loud. And I have so many friends, including my family, moving back to the United States. And it's no secret, okay?
Yeah, I can add my 2 cents. I was born in China as well and grew up there, but I immigrated to Canada, so technically I'm Canadian, I'm not a Chinese anymore. I live in California. But I visit China very frequently, so actually I can see the change of China. If you've never been to China, you don't really understand what China is. It claims to be a communist country, but it's kind of a combination of capitalism and socialism. It's different. It's very hard to describe what the type of country it is. In many ways, if you can evaluate China, it's more capitalist than many European countries. It's very different. So this is one point. Second point is even China claims to be a communist country, they allow the people to own property. So as long as the people own property, they kind of either privately own something, that can be considered to be the assets. So back to 30 years ago, it was really a communist or socialism country. People do not own anything. Like you don't own your car, you don't own your house, you don't own anything. You just you don't own yourself maybe. It's just you are belonging of the country. But now it's changed a lot. That people can own anything. You can buy just like a capitalism. You can have a stock option. You can have own your coins. So all this change make China no longer a typical communist country. In another word, China is still trying to do a lot of things centralized. That's true, even now. But I can see the trending is different, especially on the economy part. You can see the trend of the people own a lot of things. You can do a lot of things as long as you can grow the economy. But on the political side, it's still very concentrated. And I don't really see a trend they will change soon. On the political side, but it doesn't affect you can do business there. You can do a decentralized economy there. It doesn't matter. So you can still do anything like that. As long as you don't touch the political part, it will be fine. That's my answer.
Another question?
One more question from the chat. Did you make an MOU with any cell phone company regarding deployment of Elastos on their phone?
Sorry, could you repeat the question?
Did you make some MOU Will any cell phone company regarding the deployment of Elastos on their phone?
So the question is, do you have any MOU with major hardware cell phone companies that are producing cell phones? Do we have any sort of agreement with those, with Elastos? Is that the question?
Yeah. Well, the short answer is no, because if you go on to YouTube, you'll see a video of mine showing a phone we made. Actually, that phone was Android 5 Motorola Nexus. Originally, Nexus was built by Google, and later on we took the source code from CyanogenMod, because CyanogenMod has all the open source, and we took that source and translated Java class library, the libcore, and we also translated the Java framework of that phone, Android 5, all of them into C++. And I repeat, that was 4 million lines of code translation. It's not, it's kind of original, but it's not really original, you know what I mean? Because it's 4 million lines of C++. In that sense, that's original, but it's a translation of a artwork, a translation of Java Android. So the reason why I do that, there are two reasons. One is Java is not self-contained. Java cannot be used to write 100% of the applications, because when you write game engines, when you write multimedia codecs, when you write deep learning algorithms, Java is not the first choice. The first choice is still so-called a native language, which is the CPU instruction. So to solve that problem, Java's solution was leave a backdoor, so-called a JNI. So most of the code are written in Java, but the ones cannot be handled by Java, they leave a backdoor, let the developers go into Linux. So when you go down to the original hardware operating system, basically all the benefits of sandboxing are disappearing, right? So all bets are off. Virus is back, DDoS attack is back, everything is back, everything evil is back. And secondly, Java virtual machine has something called metadata. And if you have Java virtual machines in the cloud and on the phone, we can generate network packets from virtual machine to virtual machine. But somehow, Java in the 90s haven't had time or resources to get around to this issue. They're acquired by Oracle, and then Oracle somehow, let Java pretty much disappear. So that said, all we are doing in Elastos is doing it in the native virtual machine and end-to-end, managing all the traffics. That's the whole reason why we want to do this Android 5 native C++ versions of Android phone, and we did smart router at the same time, and also we built the peer-to-peer network. Well, we haven't got the time to put the three pieces together. Then our resources went out. So now what we're doing is, of course, you can think of, we still could put the three pieces together, like for telcos, for Shanghai Motor, because a lot of people ask me about the Shanghai Motor. At the same time, of course, with this kind of architecture or solution that was intended for so-called industrial IoT, for the enterprise IoT network, because a lot of for power plants, for autonomous driving, for high-speed rails, so many sensors along the lines. But then what if there's a sensors DDoS attack? What if the source code, even though the collateral, the source code, what if there's embedded source code which you haven't been careful enough to scrutinize, right? Which could launch something like Heartbleed of SSL, which was there in the open source for 20 years. And basically, whoever put it in there could listen to anybody in the world for 20 years. That was a real case, real open source problem. Every enterprise at that level, high-speed rail, and autonomous driving, they really realize that. They just don't let you guys know, because they're so afraid of people, the copycat, do something like along that line, okay? So what I was proposing, take over all the network traffics. I still today believe that's the only solution in the world, But not too many people believe in that because they're too conservative for the high-speed rail guys, for the autonomous driving guys. They're just so conservative, saying, heck, how many people do you have, right? Why don't I trust Beamer? Why don't I trust Mercedes? Why should I trust you, right? I'm just here saying that, do they have a better solution or not? I bet they don't. And secondly, people are asking me, are you still working with Shanghai Motor? Are you still working with telcos, phone, as I said? They're bureaucrats and they're too slow. And at that time, when I don't have money, I have to beg them. But now we have tokens. I think the smart web is a bigger, more exciting project. So we're not doing any of the hardware anymore, even though we could, but I don't want to anymore. And we're moving to this new venture. Thank you.
We are going to take the last question. Take the last question, hopefully from the audience here. And after that, we're going to take a group picture. And then we can have like a individual talk and a social network after that. So one more question, hopefully from our audience. Anyone? Last chance.
I guess they know everything about Elastos.
Yeah, you know everything. That's cool. All right, if no question, then we... Oh, the two. Can anyone pass a microphone?
So I believe some investors have the option to lock up their Elastos tokens for a certain amount of time. What exactly was the reason for this?
The question was, what is the reason to lock the investors' token for a amount of time, right? You want to answer?
First of all, my background is not really in the, there's a circle, different circles, right? There's a circle of traders, there's a circle of blockchains, there's a circle of doing applications. Because we did a crowdfunding with the blockchain community, and there people believe in you lock up some, basically the less circulation and easier for people to manipulate and raise the prices. And I mean, personally, as I said, we grow out of that market because we did a crowdfunding with the Bitcoin community. So we kind of respected some of the community voices. But whether they make sense, we keep our words for some coins locked up for 3 years. We keep our words. And in the future, I feel we should not interfere the market at all. That's my personal feeling, again, but then this is a community thing. If the community voted for that, I'm for the community.
So yeah, that you can vote that in the Cyber Republic, and then everyone can vote on that, something like that. And then the community can decide whether they would like to have, you know, another lockup program or whatever. The Cyber Republic will be the place to go to propose any sort of changes to not just the technology side of things, but also the economics and everything else that has to do with Elastos.
And I also, because we're facing the YouTube audience here, also because of ELA coins, I am aware of currently the market is in bear market, ELA coin valuations going down. But I want to comment because we had some blames or accuses, but then that said, as I said, you know, the less token you have, the less it's easier to manipulate. A lot of coins being manipulated for a fact, and so don't call us, you know, when telling us some coins are has gone up 100-fold. Forget about it. You should ask who is doing the real project. Okay, I believe we are seriously doing the project. We're traveling Europe, where the team is working full-heartedly and on releasing this alpha release. And in terms of you know, the sheer amount of the code, the project we're doing, I hope people have more confidence in us. And that's that. Basically, we just let the coins go wherever it might go.
Yeah.
All right. Great way to end it. Thank you, everyone. Thanks for tuning in.
Let's have a group picture.
Yeah.
Hi, come on.